All right, hello PHS UW Chem 110 students. This is Mr. Johnson. Today I'm going to be making a tutorial video that teaches you how to effectively use Google Sheets to select and paste data, organize that data into more usable forms, get rid of unnecessary data that might be confusing to the reader, and then most importantly, we're going to learn how to create a dual axis graph. All right, so let's go ahead and get started. In Schoology, you should see an assignment entitled Creating a Dual Y-Axis Graph Activity. That's what we're going to start. So go ahead and open that document up first of all. And there are two things you need to open at this point. You actually need to open up this document, the Dual Y-Axis Graphing Activity Student. That's going to open up your own personal copy that you're the editor of. And you're just going to follow along my tutorial video and you're going to do all of this work in that document. So go ahead and open up that one. And then make sure you always hit that edit button on that. It opens up a new tab with a full screen, and you want to be doing that. So make sure you hit the edit button after opening that. And then the other document you need to open up, if you go back to this, is there's a Google Sheets document right here called Size Trends and Shielding Effect Data. Now, right now, you don't know what that data is or means, and that's okay. You don't need to know what that data is or means today. Stit and I will be teaching you that eventually, but for today, you're just using this data because it's good data for me to show you how to do a dual axis graph, a dual y-axis graph. Okay. So when you open that up, it'll look like this: Size Trends and Shielding Effect. Okay, so you should have these two documents open. Note that when you open up the Google Sheets y-axis graphing activity, nothing is there. That's on purpose because you're going to put everything there as I walk you through this tutorial. So go ahead and start with the data in the Size Trends and Shielding Effect data. So here's what I want you to do. I want you to start on the table. The top left cell says atomic number. We're going to start there. We're going to click and drag to select and highlight every bit of data that's in that table, the entire data. Now, not all that data is usable for us, so we're going to get rid of it, some of it eventually, but we need to start by selecting it all. So go ahead and select all that data. And then what we're going to do is we're going to copy one way or another, whether you are using your Chromebook or a PC or a piece of fruit Mac, that'll be different. On a Chromebook, you'll Control V. On a PC, it's Control V as well. And then, strangely, on a Mac, it's Command C. So, but I'll leave all that to you. The differences between your Chromebook and a Mac, I'm going to leave up to you. I'm doing this on a PC right now, so I'll be right-clicking a lot, and I'll just be using Control C and Control V. So once you've got it all highlighted, you're going to copy all that data. I like using right-click because it's a PC and a mouse, but you'll need to do either Control C or Command C. So copy that. Then we're going to go back to the tab that has the actual blank Google Sheets document. Click on cell A1, and cells are labeled by both a column letter and a row number. So this is cell A1, that's where we want to be, and we want to now paste all that data, not paste special, just paste all that data, Control V, in. And it should look a lot like what it used to look like in that document right there. We just brought it all over here. Okay, now, having that data across several columns worked well on this page, but we don't need it to fit on one page like they needed here. They needed it to fit on one page, so they needed to make multiple columns. We don't want a bunch of different columns. We want fewer columns. So we're going to actually take these. If you notice, there's an atomic number column in A1, but also an atomic number in E1. Well, we don't need all that. So what we're going to do is we're not going to highlight the column headers here. We're going to leave those alone, but we're going to highlight starting with atomic number 19 and dragging down through the bottom of that table, which should say 36 krypton 87. So leave it there. Should turn blue anytime you've successfully highlighted something, it turns blue. If you mess something up on this, it's real easy. You just hit the Control Z or undo button, and the thing you just did, if you don't like it, it undoes it. But I actually want that on there, so I'm going to pop it back. You can undo and redo easily. Okay, so let's go ahead and take this data, starting with atomic number 19 and ending down at krypton 87, and we're going to cut all that data. Okay? And that happens to be Control X, cut. We're going to use that, Control X, and it kind of highlights it there for us. And we actually want that data to live down here, right under an element atomic number 18. So we will now paste that data right there. And you should notice that now it disappears from up here. The data that used to be up here is now gone. We now need to get rid of these column headers. They don't work anymore. So you can delete the content of a cell, or you can delete columns. You can do kind of whatever you need to. So let's delete columns E through G. We don't need those columns anymore. They're useless. Columns E, F, and G, gone. Okay. Now it's looking a little bit more usable. You're learning how to organize data to more effectively graph it right now. Okay, so we got rid of the column headers. Okay, a couple of things. For this particular activity, we don't need to know that atomic element atomic number 1 is named hydrogen and its element number 36 is named krypton. That is actually useless information for us today. So let's go ahead and get rid of that. What we're going to do is we're going to delete that column. So we don't need any of the information in column B. So what you do is you go clear to the top and you click on the B for column B. And I'm going to right click. And what I'm going to do is I'm going to choose delete that column. I don't need any of that information that gives me the name of the element. So kill all that. Okay. And it should look like that. You should now only have 3 active columns. That's going to make our graph work better. Hey, let's talk about ways to do this. Google Sheets does not know what to do with all those plus signs that you see in the column labeled effective nuclear charge. Let me show you a super quick way to get rid of, search for stuff and replace it with other stuff. There's a way you could go down and you could get rid of individually every one of those plus signs, but it's not worth your time. So here's what we can do. To get rid of those plus signs so it doesn't confuse Google Sheets, we can actually search and replace through that thing. So what you do for that is you click Edit. And one of the options is, way down at the bottom here, Find and Replace. Looks like its code is Control H. But I'm going to click on Find and Replace, and it's like, what do you want to find? Well, I want to find every plus sign. I'm going to type a plus sign in there. And I want to replace it with nothing. I want those plus signs gone, so I'm going to replace it with nothing. All right. So what we're going to do it is find all those and leave that replace with completely blank, because we're going to replace it with blank. If you say replace all down here, you should notice that instantly all those plus signs disappear. And it'll tell you it found 18 instances of a plus sign, and it got rid of all those. That's good. Go ahead and hit done. Okay, so now you know how to organize and delete data that could cause problems in graphing. Those plus signs were going to cause some columns or some problems in graphing. You just get rid of them. Search and replace with blank stuff. Okay, since we copied and pasted, turns out that there is no data in the effective nuclear charge column for element 19 and 20. The data for 19 should be an effective nuclear charge of 1, so type a 1 there. And the data for element number 20 should be a 2. It's got an effective nuclear charge of 2. And then we're not going to graph anything beyond element 20. So let's just leave the rest of the effective nuclear column blank below them. Okay. All right, so let's do some stuff here. Let's make a more descriptive title up here for column A. Column A says atomic no. But we want to make sure that the graph we make is super usable. So let's change that to something a little bit more usable in chemistry. So go ahead and click on that, and we're going to actually change that column to atomic number. And what you don't know yet is the way you determine atomic number is by knowing the number of protons. And the symbol for proton is P with a plus sign. So go ahead and just make the column heading for A a little bit more descriptive by making it atomic number, parentheses, number of P plus. All right, we're ready to create our graph. What you do is we select all the data from A1 all the way down through cell C20. So we're going to select all the data from A1 through C21. And we're going to stop there. We don't need the rest of that data. So we're going to stop on cell C21. So that's going to turn blue as always. Whenever you select, it turns blue. And again, we're going to create a chart like we did back in the Penny lab. Couple ways to do it. You can do insert chart. That's one great way to do it. Turns out there's a one-click method over here for that. That is the insert chart button right there as well. So if you want to try that, go ahead, but this is always available to you. Insert chart, bang. Okay, this is one of the few times where a line chart is actually the most preferable form. Typically, we would not necessarily use a line chart. Scatter plots usually work better in our class, but this time a line chart's actually the best choice. All right, so we're gonna use that. Okay, now we're gonna set up the dual y-axis graph. If you notice, the data in red, which is, as you can see, already effectively labeled effective nuclear charge, it's just a flat line, and it shouldn't be. We want to make that a little bit more robust line. It's just flat right now. And so what we'd like to do is actually create a dual y-axis graph so that red line is not really, really flat. The effective nuclear charge, we'd like to use up some more of this vertical graph space. Atomic radius is using up some nice vertical graph space. It goes all the way to the top over here. It goes all the way, mostly the way to the bottom here and all the way to the top here. That's effective use of all the graph space. But the red one, effective nuclear charge, is not using graph space effectively. And that's the entire purpose of a dual y-axis graph. Okay, so here's what we're going to do. We're going to customize. So we want to go over here to customize. So you see you have setup and you have customize. Choose customize over on the right over here. And we'd like to customize the series. So you can just click on that little caret there and drop it down. And we're going to make some changes that don't apply to all series. We're going to make some changes that apply only to the effective nuclear charge series, the red one. The blue one, atomic radius, already looks great. We just want to change the effective nuclear charge. So go ahead and click on that red on the drop-down menu, and we're going to make some changes to it. I like the red. Red is nice, and it looks good against the blue, so we're going to leave its color as red. You don't need to mess with the line opacity or the line thickness or anything like that. You can, as you get good at this, if you want to do that, you're welcome to. But what we're going to do is we're going to ask it to do this, not on the left axis, but we'd like it to set up a scale on the right axis. So we're going to say, please put the data in red on the right axis. Notice that that red line immediately explodes and fills up all of the vertical space in the graph. And that's the exact reason why we're doing a dual y-axis graph. All right. So that squished down red line is now a nice line that fills up all the vertical space available. And notice that now what we've got here is the numerical scale on the right-hand y-axis is completely different from the numerical scale on the left-hand y-axis. And that might confuse people, so we need to label these axes a little bit better. This 0, 2, 4, 6, 8 on the right axis, and the 0, 50, 100, 150, 200, 250, that'll confuse readers. We have to eliminate that confusion by putting good axes, labels, and titles in. Okay, so what we're going to do is we're going to cursor up a little ways. And now it's time to choose chart and axis titles. I have no real, I don't know, maybe the chart title could be a little bit more descriptive. So let's go ahead and change the chart title a little bit. Right now, the chart title says atomic radius PM and effective nuclear charge. A lot of times you don't need the units in the chart title, so I'm going to go ahead and get rid of the PM. So atomic radius and effective nuclear charge is now what's left there. But it doesn't tell us what's on the x-axis. It tells us what's going to be on the y-axis, but not on the x-axis. So let's add a little bit to it. Let's add at the end of this versus atomic number. Okay. It's often wise to talk about how what's on the y-axis versus what's on the x-axis. All right, if you notice that now the title's so stinking long that it chewed up some of our graph space, no problem. Let me show you what you do when your title is too long and too big and breaks over multiple lines. All right, and tell it, hey, I don't want it to use an auto title size. Let's go ahead and break it down to size 18. And if you notice, when I took it down to size 18, it made the title fit on one line. And it's still plenty big for people to read. So let's just use title font size 18 on that one. Okay. There's other things you can do to beautify titles as you learn more about this, but that's good enough for today. That's all we need to do for today. All right. All righty. So let's go ahead and now select. Now we're done with the chart title, but now we have other ones. You can put in chart subtitles if it needs more of a description. We don't need that today. The horizontal axis title looks great right now, but if it didn't, the horizontal axis refers to the x-axis. If it didn't look great, we could fix that problem by clicking here and adding or taking away anything we need to. But right now, horizontal axis title looks great. Leave it as atomic number, number of P+. But what we do have a problem with is both of our vertical axis titles. The one that just says vertical refers to the left one, and then you get the right vertical axis title. We need to add something in there. People will be confused. They won't know what these numbers mean, so we got to tell them what they mean. So let's click on vertical axis title, and notice now it's just blank. It didn't put a title in for the vertical axis. We need that. Okay, let's go ahead and tell it what this is. We'd like this to be atomic radius, and the units of that, you might not know this. Actually, this might be something you do know. We had you memorize through nanometer. There's something smaller than a nanometer called a picometer, and that's what a PM means. Now people will know what those numbers mean. That's the atomic radius in picometers. Okay, now let's change let's actually add the right vertical axis title, because right now there's nothing telling people what the 0, 2, 4, 6, 8 mean. We need to tell people that by again going up here and selecting from the drop-down menu, right vertical axis title. There it is. We got to tell them what that is. And you might not know this yet, but that is called an effective nuclear charge. You have no reason to know what that is today. And the units of that are just a number. So let's just put a number sign in there. The units of effective nuclear charge are just this number that gets assigned to it, somewhere between 1 and 8. Okay. All right. You have just created a beautiful dual y-axis graph. The x-axis is atomic number. The left y-axis is atomic radius measured in picometers from 0 to 250. The right vertical axis title is effective nuclear charge, and that's just a number from 0 to 8. You are now done. If yours looks exactly like this, you can hit submit. You've got a beautiful dual axis Y graph. All right, ladies and gentlemen, put that into effect. Rewind this video as often as you need to catch up with me. Hopefully I didn't go too fast for you, but that's it. It's not too hard. You will be doing a performance assessment where you demonstrate to StitNAD that you know how to do this. So get some good practice at this. All right, ladies and gentlemen, see you in class. Take care and bye-bye now.